Okay, so we are going to do the quiz review. 5.5, 5.6 quiz. I'm just going to go over the problems, see how we do. So the first question, find g divided by f of t. So just remember, I like to write that's g of t, our g of t function, divided by our f of t function. Our g of t function is t minus 4. Our f of t function is 3t squared minus 12t. Now, if you notice in the denominator, there's a common term. I could factor out a 3t. If I take a 3t out of the first one, it gives me t minus 4. Then our t minus 4s can cancel out, leaving us with 1 over 3t. Number 2, f minus g of x. So again, we've got f of x minus g of x. Our f of x function is x squared minus 1. I'm putting a minus sign, so I'm going to put a parentheses. And then our g of x function is 3x minus 5. I'm going to go ahead and rewrite it, making sure I distribute the negative into each of those terms. So we're going to have negative 3x plus 5. Combine like terms, put it in standard form. So x squared minus 3x plus 4 is our solution. Number 3, f plus g of negative 6. So it's going to be h of negative 6 plus g of negative 6. So our h function, 2n plus 5, plus our g function, n squared plus 5n. And combine like terms, n squared plus 7n plus 5. Now we're going to evaluate it at negative 6. So that's negative 6 squared. Make sure you put that negative 6 inside parentheses. That gives you 36 plus 7 times negative 6, which is negative 42, plus 5, plus 5. I believe that gives you negative 6 plus 5, negative 1 for a solution. That's one way to do it. The other way you could do it is you could evaluate h of negative 6. So 2 times negative 6 plus 5. It's negative 12 plus 5, which is negative 7. And then evaluate g of n at negative 6. So that would be negative 6 squared is 36 minus 30, which is 6. And then negative 7 plus 6 is negative 1. Which way you do it, just make sure you follow the directions of your teacher. You get the same answer either way, so it doesn't matter to me. Number 4, so we're going to take g of negative 2 times f of negative 2. This is one where I'm probably going to use substitution in there right away because I see that x squared in there. And multiplying, then we're going to get some cube stuff. So I'm probably just going to go ahead and substitute this one right away, and probably the only way I would do this one. So if negative 2 plus 5 is 3. 2 times negative 2 squared minus 3 times negative 2. Follow order of operations. Negative 2 squared is 4. 4 times 2 is 8. So that's 8 plus 6, which is 14 for number 4. All right, the graph ones. Evaluate each. So we have to find f of negative 7 plus g of negative 7. So f of negative 7, so I go over to negative 7. That's negative 1 plus g of negative 7. Oops, I'm sorry, my error. I went down, I didn't look at the functions. So we go up to the top there. I'm sorry, the f function is on top. Make sure you double check that, unlike I just did. I didn't double check it. So the f of negative 7, I have to go up. So that's 7. G of negative 7 is negative 1. So that is 6 for our solution. Erase those things. Then we got f of negative 4 plus g of negative 4. So negative 4 goes up. So that's 7 plus g of negative 4 up and down. And it's negative 4. And that gives us 3. Just going to go to blue. So f of 8 for C, f of 8 times g of 8. So f of 8 is 2. G of 8 is negative 2. 2 times negative 2 is negative 4. We'll go to green for the last one. It would be f of 2 divided by g of 2. F of 2 is 4. G of 2 is negative 6, which is negative 2/3. And you're done. Number 6, perform the indicated operation. So h of g of x, so h of g of x. Evidently, we're going to stay with green with this. So we got to find the g function. We know the g function is 4x plus 2. So I have to find h of 4x plus 2. My h function is 2x minus 3. So anywhere I see an x in this function, I'm going to replace with 4x plus 2. So this would be 2 times 4x plus 2 minus 3. So that's 8x plus 4 minus 3. So 8x plus 1. And that's our rule for the first one. Next one, find f of g of n. Again, we got to find g of n. So we got to find f of 4n minus 2. That's n squared plus 4. So anywhere I see an n, I'm going to replace it with 4n minus 2. So inside parentheses, 4n minus 2 squared plus 4. So remember, when you square something, it means to take it times itself. That gives us 16n squared. We've got minus, we've got a FOIL, so first is 4n times 4n. Oops, sorry about that. 4n times 4n is 16n, and then we've got minus 8n, so minus 16n plus 4. Negative 2 times negative 2 is 4, plus 4. So simplify that. 16n squared minus 16n plus 8. Number 8, g of f of 6. So I'm going to find g of f of 6. So my f function is 3a minus 2. So that would be 3 times 6 minus 2, which is 16. So then I have to find g of 16, not f of 16. I got to find g of 16. The g function is 4a minus 1. So that'd be 4 times 16 minus 1. 4 times 16 minus 1 is equal to 63. And find g of f of negative 2. So that's x squared minus 1 is my f function. So negative 2 inside parentheses minus 1. So that's 4 minus 1, so that's 3. So then I have to find g of 3 of 2x minus 5. So it'd be 2 times 3 minus 5, which is equal to 1. There's the first 9. And number 10, back to the graphs. Again, I like to rewrite them. So we're going to find f of g of negative 7. So I'm going to find g of negative 7. The g is my bottom function. So that's negative 1. So I have to find f of negative 1. F of negative 1 is equal to 8. There's negative 1 up to 8. Now we've got to find g of f of negative 2. So I'm going to find f of negative 2 first. There's negative 2. Go up, it's at 8. So I got to find g of 8. G of 8, go down, is at negative 2. Now this one I got to find g of negative 9 first. G of negative 9 is right there, so it's 0. So that means I have to find f of 0. F of 0, there's 0, so 6. It's a bad color. And then the last one, f of 5. There's 5. We have to go up. That's 2. So I have to find g of 2. G of 2 is equal to negative 6. Remember, the x value tells you to go left and right, and then you go up and down to find the intercept. Inverses of the function. Okay, so in my class, we wrote it as a equation first. Writing the inverse means you switch the x and the y value, so it's going to become x equals y plus 1 divided by 4. Now we solve for y, so you multiply both sides by 4. So that's 4x equals y plus 1. Subtract 1. 4x minus 1 is equal to your y value. You can leave it like that if you want to write it as an inverse f of x to the negative 1. Or f of negative 1 to the x equals 4x minus 1. Same thing. With the next one, there's n's in there. And again, my class, I wrote that as an x, as a y, and negative 2x minus 11, just to kind of help ourselves out. Same thing. Now switch the x and the y values. So we get x is equal to negative 2y minus 11. Add 11 to both sides. And divide by negative 2. So you get negative 1/2 x minus 11 halves. Honestly, if you probably put it like that, I'm not going to get overly upset. The next one says state if the functions are inverses of each other or not. With this first one, I know how to find the inverse. If I look at that and find the inverse of that, it's y equals 3n minus 3, or just 3x minus 3. There's 3y minus 3, so I've got x plus 3 divided by 3. Does that look like that? No. So your answer is probably no. Kind of look at that one just kind of by looking at it. The other way you can check is to do g of f of x. And that has to equal x. So I got to find g of f of x. So I got to find g of negative n minus 5. So that would be 3n minus 3 is my function. So that would be 3 times negative n minus 5 minus 3. I changed the n's into x's, so just bear with it there a little bit. So that's negative 3n minus 15 minus 3. That's never going to equal x or n. So since that doesn't work, the answer is no. Number 14, again, we're going to find f of g of x to see if that is going to equal x. So my g of x function is 4x minus 3. So in my f function, anywhere I see an x, I'm going to put 4x minus 3, which is a lot of fun to do. So this would be 4x minus 3 over 4 plus 3/4. They have a common denominator already. So this would be 4x over 4, which is just x. So this one works. Now I got to slide this over. And now we have to test to see if of g, let's erase that. If g of f of x is equal to x. So it'd be g of 1/4 x plus 3/4. We want that in the end to equal x. So in the g function, which is 4x minus 3, anywhere I see an x, I'm going to replace it with 1/4 x plus 3/4 minus 3. So 4 times a fourth is just x. 4 times 3/4 is 3. So that's x as well. So it works. So the answer for this one is yes. And the last one, find the inverse, state the domain and the range. Remember the inverse, by definition, changes your input with your output, your independent with your dependent, switches your x's and your y's. Okay, so there's our inverse. The domain is the x values of our inverse, so 1, 3, 4, and 5. The range is our y values, -5, -3, and 1, and you don't need to repeat it. All right, there is the review, 5.5 and 5.6.